Firstly, I'd like to acknowledge that we're here today on the land of the Guringai people. The Guringai are the traditional owners of this land, and we pay respect to the elders past, present and future. This event is proudly supported by the wonderful team at Northern Beaches Council, who have information on display on their table. More than happy to talk with you about waste and recycling initiatives, which is a key theme tonight.
Thank you, Tom, and thank you for giving me the opportunity to talk here. I might have to flick back through the slides quickly because it looks like I'm at the end. So as Tom said, my name is Marc. I'm from the University of Wollongong on the south coast. If you're interested in videos where you can see me torture surfboards, go and have a look at some of the socials there. I routinely get the power tools out to break boards that have already been broken. I have to point that out. I don't willfully destroy boards, but sometimes I just like to show what it takes to break a surfboard, which is not a lot. What I'm going to do in this short talk is talk a little bit about science and surfing, and in particular my approach to putting and providing data-driven solutions. That's actually a very rare shot of me surfing because I'm probably the worst surfer of anybody here, but what I lack in skills, I make up in enthusiasm, and I try to surf every day. So my lab is run by surfers for surfers. If students come to my lab, I generally don't look at their grade. I ask them where they surf, and sometimes I give them a sensor, and I say, go out and do some surfing, give me back your sensor so I can see what you've done. Because if people understand the surfboards and the surfing technology and they're familiar with that, I can teach people the engineering and the data approaches and the 3D printing, but the understanding and the feeling of surfing is way more important, at least from my perspective, when you start working on surfing than actually understanding the engineering. Obviously, if you have the golden combination and you know engineering and surfing, then you're on a winner. So really what I'm trying to do is I provide data-driven solutions. Everything I do, I put sensors on. And I really like to try to create and implement cutting-edge technology so that we can refine what we're surfing with. But I also like to understand what we're surfing with. And that's really why I started doing this, because whenever I went to my local shaper, they would ask me questions that I never understood. You know, do you want carbon strips? Do you want a 4 and a 6? And I never understood. And I found some people couldn't give me the answers that I wanted. So that's what led me to get into this. And through this, you'll see that I use a lot of what is called additive manufacturing technology, or better known as 3D printing. So we started many, many years ago when a friend of mine, who's a much better surfer than I am, took his school students to my lab and said, do you reckon you can print me some fins? So we did some computer-aided design of some fin designs. Here you can see some of our more advanced designs that have bumpy leading edges and grooves in it. And then we did a technique called computational fluid dynamics. It's literally like mimicking the ocean, but on a computer, so that we could investigate what happened to these fins before we even make them or put them in the lab. And we then developed some form of a performance feedback where we went between the CAD design, the computational fluid dynamics, and the printing. And of course, we did lots of testing. Here you've got Nick Clifford. You can notice he's wearing our UOW jersey, and he's giving his fins a little bit of an air. So we did 3D printing of the fins, but we obviously wanted to know what is happening when people are surfing. So in the testing that we did, we used a commercial sensor that we embedded inside a surfboard. That company has now moved into a different direction, so now we're building our own instruments to go in there. We also, and this is Brett Connellan, again putting a bit of power into his surfing, we also put sensors on the surfboard, and in the latest development that we're doing, we now have sensors inside our fins. So we put flex sensors inside the fin so that we can understand what does a fin do when you really lean, or other people, not me, when they lean into the bottom turn or go into the top turn. And then when we have the sensors, we can understand what the board does. So we can also then start looking at calculating power. And in particular, this is one example. So if you just indulge me by going through this. If you come to a bottom turn and you're going left, you're making a rotational motion. So really, if Dylan Perezi, who's the surfer in this case, if he would continue his bottom turn, he will start rotating anti-clockwise. In order to go to his cutback, he has to change his rotational direction. And that's the thing that we can measure with accelerometers. And then we can calculate what we call power into this. And we do this for about 25 other different parameters using our sensors. And I'll bore you with all the details. You don't have to look at the numbers. But one of the very first things that we did in this is, if we look from the data point of view, and I send surfers out on 3D printed fins, and I send surfers out on commercial fins, and I don't tell them what they're surfing with, can you tell the difference from the data? And the answer is no. So we showed that if we use the data and then we look at power ratings, we look at the speed, we look at the amount of rail, the bottom turn, the pitch, the U, the yaw, all the different angles, and then we could figure out that you can really show that not from the data you can't tell what you're surfing with. And that has provided us with the basis of all the further developments that we're doing. But I don't have a lot of time to talk, and I'm probably already close to over my time, but I'll go on a little bit further. So the interesting thing then is we really wanted to understand, what does a surfboard do? And that goes back to what I said about the fin. So we designed and built what we call the flex machine that allows us to test whole surfboards and then do torsional flex arrangement, mechanical flex. We can look at damping. That's a screenshot of what it looks like. We obviously use a bit of 3D printing in it. And this back end here is actually a rotating bit, so we can literally flex the surfboard, and we can also move it onto different positions. So we can actually emulate the surfer stance with 1 foot on the tail and 1 foot a little bit further forward. And then what we can do is when somebody like Dave Porter makes an EPS balsa corkboard, and he comes in and he says, how does my board compare to industry standards? We can then help him, and then in particular, we measured him. So here you can see Dave, and it's the board in our flex machine, and then we can provide him data that in certain arrangement, the torsional flex, which is given here, even if you don't understand the science behind this, you'll see that the red bar, which is the EPS board, the blue one is the PU of similar dimensions, and then here's this treehouse board. So we can tell them, yes, what you're making is very similar to some of the other commercial products that are out on the market. But sometimes I come across surfboards that are harder to get to me. In particular, here's Aaron Gold on Hawaii, and he surfs these enormous guns. So they're 10.6s, so they generally find it harder to come to Wollongong. So I took that as an opportunity to develop a suitcase version of my laboratory. Fits in the suitcase, goes nicely in the overhead compartment, and then I can go to Hawaii, which is very nice. And I did that a couple of times, mainly to work with Aaron, where I usually point out to Aaron, I said, Aaron, you're the guy that is paddling the 50-foot wave. I look at my computer. So take whatever advice I give you, and make up your own mind. But what we did with that is another aspect of boards. And this is something that is particularly important when you get to bigger waves, but also to smaller waves. And that's how vibrations travel through your board. So we do something here as a standard PU board. The squiggly lines literally mean if you vibrate, if you put, say you stomp with your foot on it, or you go through a bottom turn and the board starts moving back to its original position. You can quantify that, and you can quantify that in a number. If you do this with an Hawaiian gun, which generally have double stringers, 666 on the bottom, 666 on the deck, they don't vibrate a lot, and we can calibrate that again, so you can see that the difference in the damping behavior, so think of a shock absorbent behavior of the board, is much larger for the gun compared to what is a standard. This was a 6.3 with a 4.4 on the deck and a 4 on the bottom. And then we can use that again when a guy came past the lab and he makes flex tails, Jed Doney's, based on the South Coast, and he wanted us to validate his technology. So the bottom of the tail of the board is made out of a carbon technology. The rest is a PU with standard glassing on it. And what we did is we took a standard board, so PU board, and you can see that the body of the board and the tail of the board have the same damping behavior. When you examine the flex tail, it's very different. So we did that, and we've helped him validate some of his flex tail technology. One other thing we like to do, and I'll probably need to finish quickly, is we've come up with a way to take what is called a fingerprint of the surfboard. So we tap a board with a hammer and measure the vibrations coming out. This is not your average Bunnings hammer. It's a very special hammer that costs thousands and thousands of dollars. But what comes out of it, even if you don't have to understand what it says here on the amplitude, but you can see that the blue line looks different from the black line from the red line. Each technology and each change to the technology we can pick up. This is extremely sophisticated, and it turns out it's a vibration spectrum, but each of these technologies has its own characteristic fingerprint. So blue is EPS plus cork, black is a standard PU board, and red is a soft top that I took when my son wasn't looking. And we can use this to then start investigating what happens to the mechanical behavior of a board when you start changing it. So these lines here are these fingerprint, and you can also look here at the bottom where we have the damping behavior. So we have a standard PU board, damps a bit more than the EPS board, which has no damping technology in it at all. It's just literally glass the same way. But when we put a dampener in, we can really increase the damping behavior. And that nicely shows up, as you can see here, between the black, the blue, and the red in this characteristic fingerprint. And I really should probably stop talking, and I'll finish with, I've mentioned performance, but I also do enjoyment. So I make my own fins at home for a bit of fun. I stick them in my 20, I put the serrated knife edges on it. It's very cheap. I've been testing this. It's done in a material called PLA, which is probably the cheapest 3D printing material you can buy. That's also one of the cheapest 3D printers you can buy. And either I'm not a very good surfer and I don't put enough power in it, but these fins have been surviving for more than a year in my 20, which obviously limits it to about 3 foot of surfs. And if you're interested in it, they take about 14 hours to print. So as I like to say, enjoyment validated. I've actually completely forgotten that I'm surfing with 3D printed fins. And yes, they are a little bit more flexy than your standard fins, but it still seems to work. So hopefully what I've done is I've shown you that we can provide data-driven solutions to help development of technologies, and that we can progress performance. Obviously, if you need help, come see me in the lab. Even if you just want to come for a visit, I'm always up for a coffee and a beer, or depending on the time of the day. Or if you're interested in data-driven solutions, and obviously I need to point out, this is not just me. There are many people involved in this. And finally, I'd like to thank Jimi Hendrix for his music, and Andy Irons for his surfing, and you for listening. Thank you.
Me again. Thanks, Mark. What Mark didn't explain is that he does testing for some of the biggest surfboard shapers and brands in the world, but there's a lot of privacy around the data. Is that right?
Yes.
Moving on. So, Wave Changer is a not-for-profit that I founded a few years ago. Our mission is enabling the surf community to embrace sustainable solutions and reduce our environmental impact. So surf, sustainability, and innovation are the 3 key pillars of what we do. This is a a diagram of the organisation. So the yellow is the people involved, principal focus is the green, materials, innovation, and key considerations. So my talk is how can the surfing industry help planet Earth, explained in 10 minutes, roundabout. So surfboards, thousands of years ago, were used by the Polynesians. This is the ultimate eco-surfboard, and it is a piece of timber that was sourced locally, that was roughed up by shells, that was sealed by tree sap. So there's no reason why we can't be producing boards like this. Emil and Alistair from Sine Surf have got something that's pretty close outside, but we wear board shorts and wetsuits now. This is a timeline of a very brief timeline of the history of the surfboard. So these surfboards were around for a long time, and then in the late 50s we started to see fiberglass and foam in the middle, the performance boards. The 1980s we had the neon kind of fashionable surf mags really took off, Rip Curl, the brands really took a hold of things. The 1990s we had the technology and the machinery to do it on a mass scale. 2005, Clark Foam that produced 60% of the world's foam blanks and 90% of the US blanks. Their factory closed, they had a fire, and they weren't allowed to operate anymore because they were breaching environmental regulations. So their foam was really cheap and nasty. But because of that, it started a new revolution of materials. So where's the laser? Algae and 3D printing. So next generation materials and technology is paving the way for the future of surfboards. So most surfboards these days, which won't be from very much longer, have EPS, expanded polystyrene or polyurethane, PU, as a foam core in the middle of the board. So this isn't groundbreaking news, but what is happening now is single-use plastic items are being phased out, they're being outlawed, and it's going to be pretty much the law to not have polystyrene around. So at the moment, surfboards have that foam in the middle, so it's hidden, and there's not been any talk about banning it. And I think the majority of the world's surfboard manufacturers would take a massive kind of hit if it was to be banned. So there will have to be like a transition away from it. But it's happening with single-use plastics in the food and packaging industry. So the surf industry are inevitably going to be next. Some of the solutions that we've got right now on the market, unbelievably, this is made of mushroom root called mycelium. So this is from a few years ago and it hasn't really taken off. Maybe because there isn't the mass-produced infrastructure like there is the Thailand and Chinese factories pumping out the surfboards. But this is made from essentially mushrooms, so it's biodegradable. And this is a foam replacement. This is a surfboard with a cork outer lining. So there's cork all the way around it like a coat. And you don't need wax because when cork comes into contact with skin, even in water, you stick to it. And I've tried these boards and they're amazing. And I'm surprised they haven't really taken off. It's called a Corco by Notox. And it's amazing. You don't need wax, so that's one less environmental problem. This is Ryan Harris, who's a friend of mine in the US. He uses all of his waste products. He collects every single bit of resin, paint, cellophane, acetone. He uses everything, and he's got the world's first zero waste production facility in California. And all of those things he puts into a chipper, and you get these like little plastic pellets, and he turns them into lifestyle products that he sells on his website and in his shop. So there's no waste whatsoever. There's some really cool innovation coming out of France. This is Wyve, W-Y-V-E. They used to be called Hexa surfboards, and they are 3D printing surfboards. And it's essentially one bit of plastic. So where traditional surfboards have foam, resin, a stringer, a fin box, and all these different things, this has still got a fin box. But it's one piece of plastic that they're working on returning to the manufacturer, to Wyve, who will recycle it again. So it's kind of like a circular loop. And they perform really well, and they're taking Europe by storm. And these guys just announced recently that they're going to set up micro factories near key surf breaks around the world. So that will reduce the carbon footprint even further. The surfboards will be made, next to Bells, Huntington Pier, Snapper. There will be little micro factories producing these boards there and then, and they're custom made as well. Some of the tail pad innovations. This one here is from algal bloom that is problematic in some of the rivers in California. So they literally scoop it off the top like a scum off the top, and they make like a foam equivalent. This one here is made from recycled flip-flops, That's Nomads in France. This is Slater Designs, by the way. And then EcoPro in Portugal, they make, quite simply, cork tail pads. And cork in Portugal is massive, it's everywhere. And they're one of the biggest cork, or I think the biggest cork exporters in the world. So it makes sense to have a cork tail pad rather than something that's been derived from oil. Fins from Nomads, they've got a collaboration with Sea Shepherd, who are making fins out of fishing nets that have been pulled out of the sea, and they're turning them into fins. Sine Surf, Sine and Varuna are also Australia-based. They're using principles based on shipbuilding, so a hollow timber surfboard using CNC machines. Because they're hollow, there's no foam in the middle. They use bioresins on top. So these guys are literally pioneers in the surfboard industry, in my opinion, because what they're doing is, if you think back to the timeline, there hasn't been much change since the late 1950s. So these guys are finally disrupting the industry, and I think they're really popular. Timber surfboards are kind of making a bit of a comeback. They're quite trendy, they look cool, and they're incredibly eco-friendly. So Paulonia, which is a common timber that's used in surfboards. Do you guys use Paulonia as well? Yep. It takes, is it 8 years to grow to maturity? 6 years, even better. So Paulonia is an incredibly fast-growing timber that is perfect for surfboards. So there's no reason why we can't be using it. It's actually grown in Australia as well. And if we're going to grow materials, we can look at the Netherlands. They've got indoor farming. This is going off on a bit of a tangent, but if we're going to grow materials, not just for surfboards, but biomaterials, we're going to have to look at perhaps indoor farming, solar panels. The Netherlands are doing this on a massive scale, and they're growing food and fruit and vegetables, but they're also now growing crops for materials. So they've got dedicated facilities where they're growing materials. They're not making plastic from oil in the ground. They're literally growing it. So it is essentially a renewable resource. Seaweed as well. Seaweed's very trendy at the moment. Piping Hot, I've got a collaboration with UTS where they're making, and I contacted them about this, but it's all very, very private because of the technology, I guess, involved. But they're making clothing out of seaweed, which is going to be out very soon. And also this is Charlie Cadden, a friend of mine. He's from the island of Jersey where I grew up. He made a surfboard out of seaweed, and he actually won a competition, a global competition with Whistler a couple of years ago. So he literally got seaweed that's problematic on the beaches of Jersey, dried it out and made a surfboard, and he did put bioresin over the top, but there's no foam core, and it's made of seaweed, and it works. We can look at the architecture industry. So this is a Japanese architect called Shigeru Ban. That's not him, that's his buildings. But these are designed by him, and he just uses timber and cardboard to make all his buildings. And the cardboard is obviously on the inside, this church. These are cardboard tubes, cardboard chairs, and then timber on the outside with the, the relevant finish, the lamination or the varnish on top. Buildings that need to withstand sun, rain, wind, external elements, similar to a surfboard. The building industry is using agricultural waste as insulation. So perhaps that's an alternative for a foam core. This isn't me. I showed this slide before and someone said, oh, can I see the helmet and how does it work? And it's like, no, it's not me. I do have a ginger beard when it grows, but I show this slide because everything that is used to make this helmet is from a tree. So it's obviously a timber shell, a cellulose alternative foam core for shock absorption, and a reinforced paper strap. So everything in this helmet is from a tree. So if you look at a typical bike helmet, you would think there's no way that can be biodegradable. Well, this shows that it can. And again, this has got to be withstanding rain and shock as well if you fall off. Surfboards as well have to be waterproof and they've got to withstand shock. So we could have everything we want in a surfboard from a tree. This is a shoe from Adidas, and it's not timber. but it is plastic, and the critical thing here is that it's one piece of plastic. This is the same type of plastic. So this could essentially be thrown into a melting machine, or it chops it up and turns it back into pellets, and it can be reused. So it's a completely circular shoe. The problem, as I mentioned earlier, with most products is they've got a multiple list of ingredients or materials. As soon as you start adding more than one, it means that they're very, very difficult to recycle. So we've identified key design pillars for the ideal scenario for products in the future. Innovation is very, very critical, especially with the technology we've got now and startups and everything. Necessity. So we need to ask what is actually necessary with what we've got. Everything that we've got, I would say about 95% of it is not necessary. And going forward with the climate emergency and dwindling resources, we are really going to have to ask what is necessary. Do we need loads of cars? Do we need loads of clothes? And minimize impact. And that goes back to the materials. How do we minimize the impact of what we're making? And then designers and producers, they need to ask themselves, what happens at the end of my product's life? I find it amazing that any design school or whatever, well, maybe it will be going forward, but I think that the first lesson for anyone that's making a physical item should be, what happens at the end of the life of this product? If you're making a surfboard, what will the surfer do at the end of it, at the end of life of that product? And maybe there is a disposal plan. And it could be as simple as a piece of paper or a QR code. When you buy your product, you're told what you do with it when you finish. And I believe that a financial incentive is probably quite important. You might get $200 off a new surfboard or $100 back cash, but there needs to be an incentive to return it. But maybe we go into a leasing model where whatever you lease, if you lease your iPhone, you give it back to Apple and they reuse the materials and you get an incentive. These are 4 key principles that I think anyone making anything needs to consider today and have as part of their package of what they do as a business. Carbon offsets, regeneration projects, next-gen materials. So whatever you're making needs to be materials that are planet-friendly. And also ethical and responsible manufacturing methods. Does it have to be made overseas? Are people getting paid the right money? Does the factory have solar power? And I think it's crazy that Australia, having so many surfers, I don't know if there's another country in the world where there's so many surfers per capita. Why are surfboards not made in Australia? Why isn't the economy thriving with surfboard designers and shapers? And then we can export them to countries where they might need them, like China and Thailand, where they're currently made. But it's the other way around now. They're made in China and Thailand, super cheap, where the environmental regulations are really lax. And we can export them to China, where there's a fraction of the people surfing compared to Australia. So it's the wrong way around. This is an idea to have an expiry date on a surfboard. Not that sticker, that's not cool. But to have a sticker on your surfboard, or something on your surfboard which would say, okay, the materials in this are going to lose their properties in 2 years, 3 years. So, or it might be when you have to return it to the manufacturer for them to reuse the materials while they've still got their properties. So this is a pair of shoes. This is a random slide. It looks like it's just been snuck in, but these shoes have an expiry date. This is a German designer called Laura Muth, and she designed modular shoes that are made with nothing but plant-based materials. So there's 2 good things about this. One is that they're plant-based materials, and the second good thing is that it's a modular shoe. So when you're finished with it, you can take it apart and put it in the relevant area that it needs to go. So it might be compostable, or another bit might be upcycled or recycled to make a new material. But it's made with like hemp, dandelion, corn flour, like really cool materials, but they've got an expiry date. And why don't we have an expiry date on products? It sounds crazy, but maybe it's necessary. We could have a 5-star rating on surfboards. We've got it with appliances. We've got it with food. I'm sure when that wasn't the case beforehand, people would have said a 5-star rating on your washing machine. That sounds ridiculous, but would a 5-star rating on a surfboard look like this? The majority of surfboards now, and I'm not having a go at shapers or manufacturers, but They wouldn't score very high on the Tom Green Star rating. But, you know, maybe Paulownia timber, algae biofoam, cellulose soluble adhesive, because, you know, the glues and the logos and stuff, they're all kind of oil-based as well. A bioresin, you know, we could have this, and then there's full transparency on the surfboard. You can see what's in it, and then there will be like a race to the top rather than a race to the bottom at the moment, with, you know, churning out the cheapest, nastiest thing. I'm not even timing myself. I've probably gone way over. Sorry. Finally, the World Surf League. They get a lot of stick because they're the governing body and they're an easy target. But I think what they're doing at the moment is very good with WSL Pure. So they're doing a lot of regenerative projects. They're supporting not-for-profits like Wave Changer, but they've also, a few years ago, they've got equal salary for athletes. So right now, the WSL can't really do much more, but I would challenge them to, say, in 2 years, for example, say surfboards have to be made out of these materials. You've got 2 years to sort yourselves out, and competition surfers, Italo Ferreira, Carissa Moore, you have to be riding eco-surfboards. And it's not down to them, but it's the surfboard makers. You've got 2 years to come up with some really cool stuff. And just, we'll adapt, you know, we'll adapt. We adapted without the plastic bag, we've got our tote bags, so we'll adapt to making more eco-friendly surfboards. So that's my only challenge for the World Surf League, is to up your game with the regulations of the materials of the surfboard. Coming soon for Wave Changer, we've got a new relationship with AUSMAP, and Scott's about to talk from AUSMAP. And we think it's a world first. AUSMAP collect microplastics from the beaches around Australia, and they analyse the data. They look at where it came from, what it is. You know, this is this type of plastic or foam or whatever. So we are going to be measuring the type of microplastics that come from surfing equipment. So these guys are going to actually look at everything that comes off a surfboard. It might be 6% of what you find on the beach, and we're looking at key surf beaches around Australia. So, you know, EPS foam beads that you see on the shore, you know, those beads have come from a surfboard. That's EPS is tightly packed foam beads. It's not from bean bags. People aren't having like outdoor movie nights on the beach, I don't think. But yeah, the resin, the foam in the middle, the wax, the neoprene, leashes, fins, all that sort of stuff's going to get analysed, and we're going to put out a report, and just sort of, it will put pressure on the surfing industry. So that's my talk from Wave Changer. There's our website and our Instagram. Happy to chat afterwards if you've got any questions.
Hi everyone, my name's Scott, and that was a lovely introduction to the potential plastic issue that I'm going to talk to you about, and how we can kind of resolve those issues. I don't know if you can, I should have this up here, right? So yes, I'm from AUSMAP, the Australian Microplastic Assessment Project. So we are a national program. We're trying to understand how much microplastic is out there in our environments, and have solutions like Tom suggested, and even what Marc mentioned earlier around reducing our plastic footprint. So I'm going to give you a bit of a run through of the plastic issues. I'm sure you're all aware of it, but you know, when we look at litter in our oceans, all the big stuff, we know that most of that comes from the land. You know, where we live, where we reside, where we work, where we play are key sources, and what we do in those environments are key sources for the stuff ending up in our oceans. So litter and micro litter is an urban issue. It makes sense. It's where it comes from. It's not coming from the environment, it's coming from us. Okay, this is a photo, unfortunately, of the Cooks River, and you can see lots of plastic coming out. So our waterways, our stormwater are a major source of that litter, but also our activities on the water. I'm going to be talking about micro litter, and particularly microplastic. So microplastic is really just a size class. It's really just anything that's less than 5 millimeters in size, okay? And for the most things, it's the big stuff that ends up in our environment that breaks up. Okay, so you've got your bottles, etc. But we know that microplastics are deliberately added into our waterways, either through the products we use, and you may have heard about the whole microbeads issue and in facial scrubs and toothpaste. So, a couple of decades ago, manufacturers came up with the idea of replacing the natural scrubbing agents with plastic beads. It was cheaper, not as effective, but it gave the effect of cleaning. But every time you wash your face or clean your teeth, where does that water go? It goes down the sink. Where does that water go once it's down the sink? Yeah, in the ocean. Most of that is the grey water, right? So that goes via your wastewater treatment plants. Yeah, the sewage outfalls. The sewage outfalls are not designed to pick up the small stuff. They're designed to pick up the big gross stuff. So they just go through. And so wherever your discharge is, directly into the ocean or into rivers, they end up flowing down to the sea. So this was a big issue, but because of consumer pressure, particularly in Australia, this is now a minimal issue. Because we've become aware of it and people have made choices and the manufacturers have responded to those choices, then this microplastic issue, the microbeads, is less of a problem here in Australia. You go elsewhere around the world. I was in Singapore recently, and Singapore is a very green, lush country and very environmentally minded. But could I find a toothpaste there that didn't have microbeads in it? No. So there wasn't that awareness or that pressure to change. And that's something that I think everyone here, we all do, have the power to do to change the environment for the good. You may have heard the term nurdles. When plastic is first made, it's made as little pellets. And that is then shipped to the manufacturers and moulded into the various plastic items, a bottle or a table or whatever. Okay, but they spill. And so where you find these things, these little pellets, I'll pass it around, you can have a look. If you see these on your beaches, it tells you there is plastic manufacturing going on somewhere or in some form in the environment. And it ends up in the environment. So what we're trying to do at AUSMAP is trying to understand not only what type of plastic, but where it might be coming from, and so we can get to the solution, which is stopping it at the source. Another source of microplastics is, today, we're using a lot of clothing, which is synthetic fibres. And so every time you move around, whether it be natural materials or synthetic, you lose fibres. It comes off. But particularly when you wash your clothes, there's about 6,000 to 10,000 fibres come off in every wash cycle per garment. Okay? So if you're using a lot of sportswear, active wear, then once again you're basically creating microplastics, and that enters into the environment as well. There's solutions to that. Simply putting it in one of those zip bags, the delicates bag, will capture those fibres. So Tom mentioned about the surf industry and the issues of that, and that is another particular source. I was in Torquay a couple of weeks ago doing a microplastic survey, and the three most common microplastics we found on that beach were foam, which Tom mentioned, coming potentially from the surfboards, wax, so a lot of the waxes are synthetic or artificial, and fiberglass. So these were the three most common fibres of microplastics. So we need to be aware of what we're using and be mindful of our choices. I've also added a little photo here in the corner. This is rubber crumb. Now, rubber crumb, you think, well, where's that coming from? Well, it's coming from our tyres, for one thing. But more importantly, we're seeing a lot of this now coming onto our beaches from, I don't know if anyone live around where there's a synthetic sports field or a rubber playground, our softball playgrounds. We're finding as they age, they degrade, and the rubber is coming off the playgrounds, off those sports fields, and entering into our environments. So that, and rubber, if you're not aware these days, is synthetic, most of it. So it's all oil, petroleum based. So microplastics, lots of different types, not just the big stuff breaking up that you might think. Okay, so AUSMAP started in mid-2018 to try and understand the issue locally. We wanted to understand where it was, where it's high, where it's low, and as I said, where the sources are. But we do that by engaging you guys. It's a citizen science program. It's about education, awareness, and then training people like yourselves to help us gather the data. We can't be everywhere. Katie's in the audience with me today from AUSMAP, but we're a small team. And to get the information, to make informed decisions, we need that help of people like yourselves. So we collect it, we analyse it, and then we map it. And I'll show you some of that in a minute. So around the country, all these points that you can see, all these different coloured points are different sample points. A few gaps, obviously, but what you see, if it's green, it's good. It means it's very low microplastic levels. Once you're getting to reds and oranges, and in particular the blacks, we're seeing very high or extreme levels of microplastic. And what we find is it tends to be related to our larger settlements, so our big cities. So we've been around, as I said, so we run these training events. We've removed over 4 million microplastics from the environment, just a mere drop in the ocean, really. And we calculate how much microplastics there are per square metre. It's kind of a standard way of calculating. Okay, I'm going to pose a question to you guys. What do you think is the highest amount of microplastics we've found anywhere around the country in the amounts per square metre? If you took a metre of your beach, a square metre of your beach, how much microplastics at worst do you think we've found? Anyone want to shout out a number? 1,000 microplastics per square metre? Higher. 20,000? Higher. Not in the millions, okay. That's a lot. All right, the actual number is 780,000 microplastics per metre of shore. And if you multiply that across that shore, you then will have millions, multiple hundreds of millions of microplastics. That site, unfortunately, is in Adelaide. And it's kind of from an industrial area that drains into the Adelaide River. So it's a riverine beach that's collecting all this discharge from this industrial area. But here in Sydney, where this other big black point is, we also have very high levels as well. And unfortunately, I had a map of the whole of Sydney, but it's been cut off of our beaches. But anyway, you can see a focus on the northern beaches, or at least the lower parts of it. And so where you're seeing red, so we do a regular survey at Manly Cove, very red, and then in DY. So these are what we call hotspots of pollution. And we ran a project where we wanted to understand, well, where's this coming from? All right, we know it's high, but why? And so we focused on DY Lagoon, so DY Lagoon, not the beach. So the beach is actually low, but the lagoon is high. So it tells us it's coming down the catchment, okay? And so we not only sampled the beach, but we actually sampled what was coming down the waterways. So here's DY Lagoon. For those of you probably aware of it, there's the major DY Creek that flows in it. into it, and there's a few stormwater channels that flow as well. This map to the left is kind of the land use. The different colours represent the different land uses for that area. So the importance of Dee Why Lagoon is it's one of the last natural coastal lagoons in that northern, or in the Sydney region, really. So it's an important habitat. It's a breeding ground. It's a migratory bird roosting area. So it has lots of benefits even beyond the local environment. But what we found when we sampled, so we put nets out, you can see in those drains and creeks, and we also put in baskets along the roadsides to see what was washing off the roads. And so what we found is, quite interestingly, well, I think anyway, that the different land use types, so this is the Chroma light industrial area. This is kind of the Dee Why shops down here. This is all the high density residential, all the unit dwellings, and this is kind of standard low density housing. What we were finding is that there were different plastic signatures, microplastic signatures that were washing off. And we were quite interested in particularly the pellets and the foam that was coming from the industrial area. So foams is because a lot of packaging materials from there. So not just surfing, but depends on what's happening in your catchment. So that's then all flowing down into the lagoon and trapping there. Some of it might go out when it opens up as well. So we're finding macro and micro litter. And then we went back up and we wanted to understand, what's the comparison between the big and the small. I'm not going to show you too much data, but when we look at our traps, we're finding that most of it's micro. So this small stuff, less than 5 millimetres, is present. We're getting some big stuff, as you can see here, chip wrappers and the old sushi fish soy sauce. But in this case, lots of micro, and all those black dots, in fact, in this case, are rubber. And so we were getting over 70-odd thousand bits of plastic in that particular instance. So that's one example, and we were able to trace it back to almost the street level sources because we're putting these baskets in the drains that's coming off the street. So it's pretty, so in terms of changing people's perceptions, where we think, all right, it's the big stuff flowing into the waterways, breaking up and creating the issue, actually, and really, the only take-home message from my talk that I really want you to get is that the micro litter, and it's not just plastics, it's glass and metal and things like that as well we're finding, but it's prevalent on our streets, in our neighbourhoods, before it even gets to the water. So we need to be mindful of that as well. So that's my short take-home message. So what we've done to kind of help with that is try and develop a framework. We have developed a framework that actually works with the community, works with the stakeholders, with those people in those neighbourhoods to reduce their plastic use, their plastic footprint in this what we call a micro litter reduction framework. And so by sampling, it gives us the idea of where to target those efforts. So what can you guys do to help with the problem? Obviously, I talked about choice, and Tom presented some interesting choices as well. And we've got our waste or resource hierarchy, which I'm sure you're all familiar with. But why I put this up is recycling. If you see where the priority is, so we should rethink our products and refuse our certain products as well that might be overpackaged. But really why I've included this is recycling. We're sold this idea that recycling is the saviour. Well, recycling should be our last option because recycling is not as effective. Really about 10 or 12% is our current recycling rates in Australia. We can improve, definitely, but not everything, that should be down the rankings of choice of ideas. So things like what Marc was doing, using alternative products. So with his fins, he was using PLA. So that is a bioplastic. And so that's a nice product to be using. So I just wanted to, and so we're talking around 9 Rs. I don't know, when I was a kid, we might have had 5 Rs or 3 Rs, but now we've got up to this. But anyway, so if you rethink, go through all those steps before you get to the recycling. Get involved is the other, or the last thing I'm going to tell you about. So AUSMAP's part of a group. You may have heard of the Strauchel. It goes down at Manly Cove every month or every couple of weeks in the warmer months. And Strauchels are snorkels for straws. We also do a microplastic cleanup every month, the first Sunday of the month. So definitely you can get involved with your local action. And as Tom mentioned, there's initiatives with the surfing industry in particular. But I think the power, as I said at the beginning, is with us to lobby our local MPs, our manufacturers and we've got some local manufacturers here. So it's important to talk to them if they're not already on board. But find your own area, find your own community and work with them. But if you're interested in helping us out in getting some data or participating in the Strauchel events down at Manly, then just contact us and we'll be able to help you find your own little tribe to work with. So I'll leave it there and say thank you very much.
Hi everyone. My name's Tully and I'm here tonight to talk to you all about Surfers for Climate. Unfortunately, Josh, our CEO, was supposed to be here tonight, but he wasn't feeling well. So he's actually put together this lovely PowerPoint presentation and a few notes for me, so I am going to be looking at them. But I just think it's really important that we can share the message of Surfers for Climate to as many people as possible, so I hope I do it justice. So our vision at Surfers for Climate is to ensure that we see surfers riding waves in thriving oceans for generations to come. That's our goal. We're a Sea Roots movement, mobilising and empowering surfers for positive climate action. So our values matter. They're what keep us focused and inform every aspect of what we seek to do. Most importantly, we recognise the true locals and honour our First Nations connection to country and culture. We practice bold inclusion. It's people of all colours riding whatever the hell they want. Our co-founder Belinda Baggs is a longboarder by trade, while CEO Josh is a bodyboarder who's competed on the international stage. Bold inclusion is a value that provides strength to the organisation, but we're thoughtful larrikins. Climate is a depressing subject these days, but instead of crying in the corner, doing nothing, we'd like to take the piss out of what we can and try and enjoy the task at hand. We love to collaborate and connect with like-minded organisations such as Wave Changer wherever we can, and lead with respect for the earth, the ocean and each other. Our main goal at Surfers for Climate and what started it is just thinking what happens after the big paddle outs. So some of you may have been involved in the paddle out for PEP 11 or the Fight for the Bite, and they're amazing and you see the surfing community out in force in these things. But the question for Surfers for Climate is, does this action end there? Is there more to do? Yes. But just saying yes isn't enough. We recognise that what you do after saying yes is hard work because all surfers are at different levels of engagement with climate action. We believe that surfers need to start climate action from where they're at, not from where they wish they were on the issue. So this slide was selected by Josh. Go back. This slide was selected by Josh and was meant to get a laugh given he's a bodyboarder. but it's also an image of truth for Surfers for Climate. So there are different takeoff points for surfers depending on who they are, their level of engagement with the issue, and yes, even the craft they ride. Even if you're a swimmer, body surfer, anything, it all counts. If every surfer is unique, then every surfer needs their own climate action journey. And for Surfers for Climate, the best way to communicate this is to use Point Break as an example. So surfers need a point break. Well, not this kind of point break, even though it's a classic, but every surfer needs a point break of engagement that lets them drop in on climate action wherever they're comfortable. So their takeoff point might be listening through their own terms. That's why Surfers for Climate has launched a podcast series called Car Park Convos, which has so far interviewed politicians, experts on superannuation, startups in ocean impact space, shareholder activists, environmental champions, and also a diversity of voices from the surfing world as we recognise it. So they might want to take off with better consumption practices, which is why Surfers for Climate launched the Sustainable Supply Club. So the Sustainable Supply Club brings together over 30 brands and counting. They're all producing better goods, and by making these goods available to Supply Club members through discounts, educational opportunities, and monthly giveaways. We never recommend that people buy more stuff. It's just a matter of when they have to buy something, they buy better, and we help guide them towards those sustainable brands. It's also an important way that Surfers for Climate can raise money in a win-win scenario for brands, members, and the organisation. So some people might want to engage in climate action through live events in their local community. So recently, some people might have attended the car park cinema at the Harbour Hilton, or the Harbour Hotel. That was a really cool event if you managed to drop by. So this car park cinema series was conceptualised and tested by Surfers for Climate and recently delivered in partnership with Surfrider Foundation and Patagonia. These live events have taken place around Australia and delivered high quality opportunities for knowledge exchange, from panel discussions with a variety of climate actors, while also delivering some enjoyable surf films, which we all love. Thousands of surfers were touched by this initiative, and it proved to be an experience that surfers will show up for and engage in. Some surfers want to engage in climate action through First Nations knowledge and culture. So this is why we recently launched our Walk on Country and Bush Tucker Walk initiatives. These experiences have been funded by us, and those who have shown up have proven to be highly engaged, and it's an effective way of sharing Indigenous knowledge and building more inclusive understanding of our coastal environments where all surfers play. This particular initiative is one which we're actively seeking larger funding for and hope to scale up around Australia. The big announcement tonight is that it is a very easy way for surfers to engage in climate action is to learn about it in the safe space that is the local pub. The Salty Brains Surf Trivia is launching next month in partnership with Stone and Wood and the Harbour Hotel. There will also be a pilot event in Torquay. The event is the idea is that surf trivia, sprinkled with a little bit of climate knowledge in the safe space that is the pub, is a very easy way for us all to build the movement and help surfers learn more about the issue that is the climate. We're really excited to launch this next month and plan on scaling it up Australia-wide and ideally hold bi-monthly events, which will be cool. Some surfers want to engage in climate action with their votes, which is the biggest climate impact they can have. Obviously, it's pretty prevalent at the moment. So we launched the Don't Cook It on Climate campaign a little differently than most. Instead of asking people to say no to something, we created an open letter with policy recommendations for all candidates to consider, such as creating a marine management trust, launching an ocean impact business agency, and shifting subsidisation of fossil fuels to farming. This message will be ours for a long time yet, and we look forward to helping our community not cuckoo on climate at every election that comes along. Here's the branded shirt we sold to raise money, which gets the message across. So, about politics, where do we sit? Well, left, right, green, and everything in between. We're seeking bipartisanship on climate action in this country. We don't believe genuine climate action can be sustainable without all politicians getting on board. So we engage with pretty much anyone with a genuine interest in taking climate action. It's that thing about being, this just focuses on the thing about bold inclusion again. So you can be a body surfer and vote whatever way you like. We have a home for you if you want to go on a journey at Surfers for Climate. Families enjoying waves and hoping to leave this place a better place than where they found it for their kids, they have a home at Surfers for Climate. Women dancing on waves, wanting a stronger voice in politics and climate, all are welcome. And this one, the last one, that's Josh having a crack. The boogie board community, always chasing slabs in crazy places. They have a place at Surfers for Climate too. He wanted everyone to know that that didn't end well. So yeah, we just want anyone that's interested to join Surfers for Climate. You can look it up on Instagram or we've got a really cool website too, and there's heaps of information. The podcasts are really interesting too if you just want to learn little snippets of cool things. And yeah, it's a growing movement and we want everyone to be involved. So thanks. Sorry for my reading.
Following the interesting talks, we had a panel discussion to find out more from the speakers and put some questions to the audience. Our special guests, Emil and Alistair from Sine Surf, joined us on the panel to let us know more about their sustainable timber surfboards. We highly recommend checking out their surfboards. You can find out more about Sine Surf and the other guests in the links below. But yeah, thank you very much for coming. And thank you very much for watching. If you like this content and would like to support our work, you can make a donation by clicking the link below. This will help us immensely to continue our research and future projects. Thank you very much once again, and we hope to see you next time.